Welcome to our webinar. I love agent-based security. Said no one ever. My name is Roger Hale. I'm the CISO in residence at YL Ventures, and I'll be moderating today's event. You'll see a Q&A box in the Zoom interface. Feel free to input your questions there, as I may pose your questions live to our expert panelists at any time. Today for this webinar, I'm joined by three cybersecurity experts. Please introduce yourselves and share something about your IT environments. Let's start with Drew. Drew, are you there?
Can you hear me?
There we go, Drew. Now we have you.
Sorry, connected there for a second. I'm the Chief Security Officer at Big Data Security providing a data lake exchange. I've been at Cubicle for 4 years, managing all aspects of security.
Doug?
Yeah, good afternoon, everybody. My name is Doug Graham. I'm the Chief Security Officer and Chief Privacy Officer at Lionbridge. We have a very diverse IT environment. It consists of on-premise technology. We've got technology in AWS and also in Microsoft Azure.
Thank you, Doug. And Avi?
Hi, I'm Avi. I'm the CEO and co-founder of Orca Security. In fact, I was involved in cybersecurity most of my adult life, been a decade in the Israeli intelligence and in Checkpoint for the decade afterward, the chief technologist in the last few years.
Fabulous. Thank you, all three. Avi, just to start this off, as the co-founder and CEO of Orca Security, what problems is Orca solving for, and how are you differentiating yourself from other solutions?
Thanks. So in order to answer that, I'd like to explain a bit how we did in fact security posture monitoring before Orca and what are the problems that we are trying to solve. So back in the day, before we had cloud environments, we had hosts. We wanted to secure hosts, and the most trivial answer is to install security agents on them. Naturally, they reside on the host. They can have full visibility to anything that is running them, detect any rogue activity in the OS application, detect data that shouldn't be there, etc. The main issue that I'm sure all of you know is that you need to install them. You need to install, you need to maintain, you need to upgrade them. And if they are not installed and maintained, you're simply invisible. They are simply invisible to you. So a different approach that we used to have is to try to scan from the network, deploy network scanners that try to probe things externally, either using authenticated or unauthenticated mechanism. And these were basically the option that we have on the pre-cloud world. If you think about it, if you want to scan physical machines, there's absolutely no alternative rather than installing agents or scanning from the network. So we've used these two mechanisms, although they are far from perfect. When the cloud came, what we actually did as an industry is to copy what we had. We had a network scanner, physical network scanners. Now we have virtual network scanners. We had agents that ran on the environment, on the physical machine. Now they are running on the virtual machines. And we simply added another beast, the Cloud Security Posture Manager tools, that monitor the cloud configuration itself. So things like the networks the machines are sitting in, the roles, etc. And we basically ended up with having the three cloud tools moved to the cloud, augmented by the Cloud Security Posture Managers, tools like Redlock, Dom9, etc. But we saw two main problems that we wanted to solve. First is the problem of agent deployment, that it does not scale. On average, we saw that organizations have less than 50% of their assets are covered by all security solutions. It's almost impossible to deploy everywhere. There is a huge intra-organizational friction in order to get it deployed. And even organizations that put people working full-time to deploy that resulted in a very, very limited deployment. And the second problem is there are simply too many security alerts. On average, you can see approximately 10,000 vulnerabilities to every 100 assets. And the reason for that is simply because these tools work in silos. They don't really know the overall picture. So I'll just give a very simple example to explain what I'm talking about. Let's say that you have an internal web server which is open only to one person, which is vulnerable to a critical remote code execution vulnerability. And the same version of code open to the internet. Naturally, the machine which is open to the internet is much more riskier than the one open only to the data science team. But when an agent runs on a specific machine, it doesn't see that. So it simply sends all of the alerts to the security team, and they need to combine this data manually, and they cannot really do that because these tools don't see the overall picture.
So talk to me about how Orca is solving this in a different manner. What's the differentiator that you're actually showing in your thought process and in your technology?
Okay, so we thought about, is there a way to do it completely different for the cloud, to understand that the cloud is no longer a set of physical machines sitting in a dark cold server room connected to the network, and to utilize the fact that everything is virtual and running on the shared public providers. And we came with a technology that we call side scanning. It's a patent pending technology that we've invented that have several unique benefits. First, it provides complete coverage. The entire cloud estate is covered within minutes and providing superior security, much better than we had in the local data center. And I know this promises a lot, so let me explain a bit how it works. So first, we don't require any agents, we don't require any network scanner, we don't require any CSPM, nothing like that. And yet, we're able to detect the risks within the workloads without any agent, without any scanners, literally without sending a single packet, without running a single opcode in the environment. Instead of interfering with the environment, we collect the data directly from the workload's runtime block storage. This is, in fact, the unique differentiator and the secret sauce about Orca, and we combine it with the cloud metadata. Instead of integrating with each and every workload, requiring network access to it, requiring credentials or installing agents, we read it from the common shared virtualization environment. And this allows us to gain the immediate understanding of everything, of all of the major risks in the environment. So in the end, you're getting a much more comprehensive visibility because you don't need any parasite integration. It's complete. We detect everything that exists now and in the future. It's not like you manage to deploy it on 100% of the environment and it's going to go lower because you haven't added people to maintain it. And it's 100% zero impact. And it absolutely doesn't have any effect on the workloads because we don't install anything on them. We don't change anything on them. With Fortune 500 customers that onboarded their entire cloud estate within a week, and there's absolutely no other technique that could allow that. After they integrate it, we are able to detect the risks that matter most. Things like vulnerabilities in the OS packages libraries, misconfigurations, machines that are already compromised. We call it the neglected workloads, machines that nobody has been maintaining in the organization for years. Many times they're already compromised by the time we see them. And the sad thing about that, it's very easy to detect if you reach this machine. It's always a matter of reachability. Risk of lateral movement, machines that have keys that can allow accessing many others. We see it all the time that due to poor hygiene on some machines, someone left AWS keys that have root access or SSH keys that allow accessing the entire environment, etc. And we do all that for all of your environment, literally within minutes. So at the end of the day, we are providing the superior security because it's agentless deep scanning. We're able to see the risks in each host, but we put it within context and prioritization based on the cloud configuration. This is a cool thing that the cloud allows us that what didn't exist on the pre-cloud world. You don't only see a machine, you understand its location in the fabric. You understand whether it's connected to an internal network or external network. You understand which ports are open. You can get all of this data in a very normalized fashion that allows to provide an holistic prioritization and understand which risks really matter more for you. So let me just take another minute or two to explain how we do that, because many people don't really understand how it's possible to read all of this data without talking to the environment and what was in fact the change that allowed it. So let's look at machines and environment and how we reach the situation that existed today. Before the cloud was used, before virtualization, we had hosts, physical machine with CPU, memory, and disks on them. And we had on this running the operation system, application, and the data. When virtualization came, we simply ran on the same virtual host, and same physical host, few virtual hosts. And after that came the concept of virtualization clusters. Why should I care on which physical machine my workloads run? Let's just take a bunch of physical machines and treat them as my shared pool of resources. But it didn't scale very well because of many cases you needed to move data. So the manufacturers moved to an architecture where the storage, in fact, sits physically on a different box. There is the shared storage box connected via high-speed fiber optics and shared between these physical compute nodes. And what we do in Orca is that we run on an independent host, an additional virtual machine, that the setup is done by granting it the read-only access to the account storage. And when we get that, we absolutely don't affect the host because we don't run on the host, we don't talk with them at all. We get the view to the data, the virtual drives, and then we start assessing it. We virtually reconstruct the bits and bytes to the block levels, and then we reconstruct the file system. We build the operation system, application, and data all on the virtual read-only view, and look for any risks that are found in them. So we in fact have full runtime access to everything that the host uses. I mean, it's not only external black box view, it's white box. We see every bit and byte on the system. Now we take this view to logically ingest security into the environment. We scan the block storage of the running virtual machines and continuously analyze your environment without any agent, without any effect to it. So at the end of the day, I truly believe that this is the right way to do security in the cloud. First, you get complete visibility. You see exactly what the host sees. It's runtime, it's not initial time. It's immediately attached. New host don't automatically scan, no need for organizational friction. Absolutely zero impact, read only. We scan on our host, we don't have any performance penalty. There is no way it can create any effect to the workloads. Completely VPC agnostic, no need for credentials, no need for integrations with other systems for that to work. And another cool side effect, it's tamper-proof. Because we don't run the scanning code on the target environment, even if the host is compromised and have rootkit, it doesn't affect us. So this is the seamless delivery that we're talking about.
Okay, that's a really, really fast overview of what's going on. And, like you mentioned, some people may not quite, buy this, the proof is in the pudding kind of comment. Unfortunately, today we have two individuals on the panel that have both implemented and are implemented and working with Orca. So, let me start actually there and throw this out, to actually ask, what is the approach? What's the approach that Avi just took us through that resonates with you? And Doug, let's start with you.
Yeah, sure. So the timing was interesting for me when Avi and I first met and I was introduced to Orca Security. Effectively, I was a new CISO. I just joined my current company. And what you're asking yourself as a new CISO is, what am I responsible for? How well is it configured? And how effective is it maintained? Are we good at patching? Do we even have an understanding of what all our hosts and agents and virtual machines look like in the cloud? So I really needed to understand that, and I needed a consolidated view that was both across my AWS infrastructure and across the Azure infrastructure, and I needed it fast. We had and still have, as it matters, a vulnerability management system that we use for our on-premise technology, and we considered that. But as a new CISO, where you're still building your credibility with the organization, Actually, it's hard enough when you've been around for a few years approaching your DevOps teams and saying, hey, can you take this agent and install it on every virtual host that we've got in the environment? That's a difficult conversation to have, and you probably don't want to do it without some testing and some verification. And when something goes wrong, you typically get the blame for everything that breaks. So I really didn't want to take that approach because I wanted something that gives me fast results. And I wanted something that was going to be accurate as well, so that I didn't want to count on a complete agent deployment, because any forgotten hosts wouldn't necessarily give me information, because if the host was forgotten, the agent might not get on it. So the other thing is we're worried about is just the operational impact and the load and the balance. So what I found with this solution is really just by very simple configuration that took minutes rather than hours or days or weeks to roll out an agent strategy. We were able to get insight into both the Azure and the AWS environment really quickly with a high degree of accuracy, so that when we start having the discussions with the teams about things that we should be doing better, I knew I was going to be coming from a position of credibility, because the approach it takes is always going to be highly accurate, because we're reading the configuration as code rather than counting on inference that comes from the agent-based approach.
So if I was going to distill that down into a one-liner, something around inside across disparate cloud and with a near frictionless implementation process.
You should be in marketing. That was pretty good.
No. I'm a CISO. But then I don't know. Hey, Drew, your company, you were, you could almost say almost born in the cloud. So was it a similar thought process, or what was your approach?
Yeah, I think that what Doug said resonated really well with me. I think there's a few things to think about. So Doug had mentioned that he was a new CISO and he was looking to get a quick measurement of sort of a snap count of where they were on security. And I think that that's always important for someone coming into an environment. Whereas I've been at Hale for some time, so I do a reasonable measure of what's going on in security. The thing that I had encountered more times than I would like to admit is when we went to deploy some technology that was most likely agent-based, is the process to get it deployed was just absurd in terms of length of time and complexity. Now, agents themselves are not complex, but especially in a cloud environment where you are scaling up and down ephemerally, possibly thousands of times an hour, which we do over multiple clouds, and you have a CI/CD pipeline that builds your infrastructure. You have containers, you have virtual machines, you have the whole 9 yards. Agents can be a little bit challenging, and we've encountered a few things. One of the things that was most annoying about agent-based approaches was that they tend to be more traditional in thinking about things and tracking hosts and systems by an IP address or by a network or by a name. And when you're ephemerally launching thousands of these hosts an hour, that's difficult to track, and it fills up the database, and it makes it very difficult to analyze and go through that data. Secondarily, when there's a new agent that needs to be deployed, those agents have to be baked in. They have to be what we call in our process. We have to test, evaluate, and then we bake and then soak it into our environment. And that can take weeks to soak it all the way through the environment, which again is fine as long as the agent isn't changing all that frequently. But if the agent is changing once a month or more than once a month, then that becomes an enormous time sink of someone on my team that has to keep track of those agents, keep track of the status. And when we got to change out these agents, typically the vendor provides the agent, but they don't provide any of the code to operationalize getting the agent from one stage to another. So that's one of the things that we've had to do with our own code is actually write the code to test and then deploy and validate that the agents are where they need to be.
So that's putting that into your entire production environment, your entire change control environment, you know, instead of giving you an opportunity to have that visibility in kind of an out of band process.
Yeah, the
Exactly, and I
stuff's
think,
really important. Sorry, Drew, keep going.
I said exactly, and I think the other thing to think about is that whole out of band process can be extremely expensive in terms of maintenance and upkeep. Because you have to make sure that you're getting the newest features, newest capabilities, and you can't underestimate. I mean, you really, really can't underestimate what Doug said. That what if you forget, you know, a host or a container over here that doesn't have the agent, then you have a false sense of security where you were expecting security to analyze and report on vulnerabilities necessarily that it doesn't know about, so it can't report on it. And I think that that's a huge opportunity to miss. Whereas things like Orca, or at least Orca, I don't know if other things do this really, they're attaching to the cloud infrastructure itself, so you don't miss those things because the cloud infrastructure itself is aware of all of the systems attached to that account.
Doug, do you wanted to follow up on that as well?
Yeah, I was really going to underscore that you can't, I think, underestimate, or it's easy to underestimate the amount of work that it takes to really do this in-band, as Drew was talking about. I mean, as you start looking at a broad deployment of a vulnerability management solution, you need people to run that and to make sure the agents are getting redeployed, make sure they're getting upgraded, make sure that they're not creating traffic problems. So the out of band thing is as I laugh sometimes and I say it's so easy that even a CISO can do it, as far as pushing the technology out across the organization. So I really just want to underscore the difference there and how much easier it is.
Fantastic. Hey, I want to pivot just a little bit, and Avi, I want to bring you into the conversation with our webinar attendees. There's a couple of questions out here, and I think that the few of them are actually interrelated. So I'm gonna put this, kind of categorize them a little bit. One of the questions from the webinar audience is talk about the type of workloads that you're handling.
So our philosophy is to scan and help you with everything within your side of the shared responsibility model. So focusing on the compute infrastructures, both containers and raw VMs. So this one we are able to scan for all of the code and application, misconfiguration, vulnerabilities, even to the library level, including recursively to containers, including in cases that use Fargate and similar modes. And for the services where it's in fact the cloud providers, we are focusing more on detecting the configuration. So if, for example, you use a managed database, we look at the configuration because the code and the vulnerability is mostly on the cloud provider side. And of course, for the data itself, we are also able to scan it for both vulnerabilities if you have a web server in S3 or for a PII that is misplaced or malware.
Fantastic. So I'll give the audience a chance to follow up on that. But the other questions that come in, and there's a couple of them, maybe the same person, maybe not, because anonymous attendee. Let's talk about data that's in memory and vulnerabilities within memory. How do you address running processes and those vulnerabilities in memory?
So at the end of the day, the main focus here are on things that can get you breached. And they come from memory, to the memory from the block storage. So if you launch an application, the application still starts on the block storage and then run on the memory, including its configuration, its log file, etc. So we're able to see the exact version, the exact runtime configuration, etc. from the disk. And we are also able to deduce the exact way it's running from the log files. So we do scan also for malware, and it's true that we scan the disk for malware and for residue and compromise, not the memory, but the focus is really about the thing that can get you compromised. For example, when I said risk of lateral movement, the focus is things, for example, misplaced keys or misplaced AWS or misplaced cryptographic keys that can allow lateral movement from your machine to others. And all of these can be found in the disk. I can give several real-life examples. There are several cases where we saw that an environment had a neglected web server, and I really say neglected, one open to the internet that haven't been patched for years. And on the same machine, you could have had AWS key that allow almost root access, or SSH keys that allow SSHing as root to many parts of the environment. And all of these are stuff that is on the disk.
All right. For the audience, if there's a follow-up question for that, please go ahead and put that in. And we'll go ahead. And there is one more that just jumped in. How do you find AWS keys that are on physical machine developers' use that can be harvested?
So we are in that area. We are focusing on the cloud workload, on, for example, a web server, where someone has put the AWS key on that machine or cloud environment. We're able to detect that you have an AWS key that is stored there and its capabilities.
Fabulous. And then follow-up question, are you blocking or only detecting? I could answer this one, but I'll let you answer.
So the focus is detection and integrating with systems that allow taking the corrective action. So we can run a rule base that allows taking a corrective action based on your preferences, whether it's a violent action or creating a ticket.
Awesome. All right, well, so the audience comes up with a few more. Let me go ahead and jump in. All right, everyone is talking about shifting left security or shifting left. So what are your thoughts on shifting left? What part of security should shift left, move into the CI/CD process, and what should be done post-deployment using tools like Orca? Can you do everything solely on the left side?
Let me jump in on that first. I think when we looked at this, we took a philosophy, and I've taken a philosophy that the security tools that we are deploying and the orchestration that we're getting need to become available to the people that are doing the work. So in some aspect, I think shifting left means shifting the viewpoint into your security tools left as well. So for us, a big part of this was, as we deployed it, all my DevOps team have been given access to the platform. Our infrastructure engineers have been given access to the platform. And the direction we've got is for them to be able to use it to drive their own assurance and for the security team to be able to go in and verify that with a trust and verify approach. So I'm sure Drew is going to talk more about shifting left in the process, or maybe Avi, you can dive in around the DevSecOps concept. But just from a pure, simple, quick value, shifting your tools left so that it's not just a security team that's pointing at issues and tripping people up, saying, "Hey, you're an idiot. You've misconfigured something," or your process has failed, becomes valuable right off the bat.
I'd like to jump in there. I think that, yeah, exactly, Doug. I think that there's a lot of people who are focused on this concept, and it's not an invalid concept. I mean, especially the cloud where, your workloads become ephemeral, it becomes extremely important, really, that things are done in an automated way so that things aren't missed, because some of these decisions, some of these lights out management decisions that happen in cloud infrastructure take mere moments to happen, and you can't have people doing it live. I think that any approach needs to take both into consideration. I think if you can script it, if you can build it into your pipeline, that's the way to go. But you should always build into your pipeline a way to do any of those things in an ad hoc manner so that you can test and validate. You basically trust but verify that what you're seeing and what you're hearing from the automations and the service infrastructure as code is correct. And I think Doug hit on this a little bit. But at the end of the day, I tell this to all of my companies. Every person in the company is a part of the security team. So as much as I could get them involved in understanding how important these things are, it's so much more important to the company as a whole to have their active participation in not only solution management, but problem identification and security as well.
Yeah, I agree. I mean, going to the process is also very key, right? Making sure that the processes are right and using what you're seeing to go back and fix the processes is the bread and butter here. But I don't think I've ever been in a situation where things don't deviate from the process. And when that happens, there's going to be an impact. And it's when you've got these deviations from the processes that you end up with your orphaned hosts and things that people forget about. And it's the outliers from the process and almost any security or IT process that ultimately cause the problems there. And this allows you to spot that.
Thanks. In fact, I couldn't agree more. At the end of the day, security is about checking and checking and checking in different areas. We should, I'd wish that we come and all of the system that we scan will be green and we don't detect anything because everything went well from the CI/CD pipeline and never deviated. But unfortunately, as a security professional, this is rarely the truth. And so saying, we believe that we've done it right on the first place, therefore it should be secure, is simply ignoring the fact that you need to monitor. So we definitely believe that as much as possible security should be in the first place on the CI/CD pipeline, but we can't assume that it will work without actually verifying what actually happening on the right time. This is my philosophy to that.
Fantastic. I think we beat that one up fairly well. Jumping back to our webinar participants' questions, just a quick question, then back to the agenda. Are you able to identify privilege escalation possibilities?
Definitely, yes. We detect it in many cases. By the way, one of the cool things that some of our customers see is that we detect it holistically. We don't detect it only in the concept of a privilege escalation on a specific machine, but in the cloud itself as a whole. So for example, if you have a private key that is, an SSH key that allows lateral movement from one machine to another, and this machine have AWS key, this is a privilege escalation risk from within the cloud, not only in specific machine. And because we are not just an agent that runs on specific machine, maybe I can even, so it looks, we can tell you, for example, that there is a risk of lateral movement risk. Let me jump down to that. From that specific machine to others. And it's, this is a very simple case that there is a private key that allow moving from one place to another. Just, we've seen customers that had in the CI/CD, in their Git repository, keys that open the entire organization, literally that. Every machine had an SSH key trusted by all of the production. And these are, the things that are like gold for the attackers, but at the end of the day, there is no good tool to detect them. Or even if it's detected, it misses the context and priority. There are tools that will tell you there is a private key or something that seems like the private key, but they won't tell you which machine it can open. Due to the fact that we see it holistically, we're able to tell you the capabilities of these keys, the actual risk they have.
Okay, I think I just lost a year of my life on that one. So that's a great question from the audience. So let's talk about the approach to allocation resources. And Drew and Doug, this is for you. And maybe Doug, we can start with you on this. So what's your philosophy around a good security program? How do you allocate your resources, people, and technology? And we actually have a question from the audience that I think will actually roll into this conversation as well. So for the question on the QA board, we will get to you on that.
Okay, so I think when it comes to resources, you have to prioritize getting the basics right. and we've spoken about them, and I don't want to beat them to death here, but it's knowledge of what you're protecting, it's the configuration management process, it's the patch management processes, and these are equally as valid in the cloud as they are in an on-prem environment. But frankly, these aren't the things that security does. These are the things that security is always trying to get other people to do. So, you know, we'd mentioned earlier on putting the tools and it actually means putting the trust in the people that are best positioned to do that work. And we call it hygiene. Many other people do. Obviously, I haven't made that term up. But then we have to be able to verify. Once you start to get these things right, then that allows you to kind of move up the stack, start looking at advanced threat protection, looking at IPSs. But really, until you've got the basics covered, it's very difficult to move into the more complex aspects of security. So I'd say start there. That's where we prioritize. And I want my gifted and talented security team working on the difficult problems and not solving what should be the easy problems of frankly inventory configuration and patching.
Drew, does that align with you know, the starting in the cloud, you know, cloud first?
I think so. I think the one thing that I would say I did hear Doug say that was pretty critically important for me was what are the assets you're trying to protect? You know, in a cloud environment, are you trying to protect your own internal IP, customer data? Are you trying to protect the infrastructure? Are you trying to defend against the denial of service attacker too? You know, so you have to understand what the stated goals are as well. But everything that Doug said was definitely very valid. But you have to also understand what the stated goals are, because that's going to outline where you're going to want to spend your funding. Because obviously the more important assets, you're going to want to spend more of your resources. There's always going to be some place where you're going to have to neglect things that you know, you'd like to spend more money there, but you know, you just ran out of funds.
Thank you. So there's a question from the audience, and I'm going to throw this open. I think it should be an answer across the board, though. The question is, how do you assist in prioritizing for remediation work? So, you know, obviously you're identifying these vulnerabilities or these SSH keys that are there, these privileges. But how are you supporting an organization? And maybe Drew and Doug, you know, maybe you can speak a little bit more closely to what it looks like for you. But how are you supporting being able to prioritize remediation within this process?
I think the prioritization becomes easier and frankly a lot more obvious when you've got good information in front of you. Traditionally, when you're looking at vulnerabilities and correcting vulnerabilities, there's a lot of things you've got to take into consideration and things that may not be available to you. You know, clearly you've got the severity of the vulnerability, but the picture is often missing as to how accessible is that host. Now, sometimes that's an obvious thing, right? If it's a vulnerability that's related to the web channel and it's sitting on facing the internet, then it's perfectly obvious. But sometimes it's not so easy to see what is actually internet facing when it's kind of buried back some deep layers into your VPC. So a lot of this really comes down to really understanding the combination of the severity of the vulnerability, the network accessibility, the ports that are open, the availability or the possibilities to then move laterally if that is exploited. And once you've got all these elements coming together, when accurately portrayed, for us it's become quite obvious where we should be focusing first, right? You start on the most serious vulnerabilities and you work your way back from there. And it doesn't take a lot of what I would say expert interpretation to figure that out.
Avi, it's
Yeah.
for you as well. I mean, how do you see this question and the support for prioritization remediation as part of the Orca solution?
So this is one of the things that we really put a lot of focus on, because at the end of the day, to give you thousands of vulnerabilities, or in larger environment, millions of vulnerability, doesn't help anyone, because you can't really handle that. So we tie the configuration, the cloud configuration, to the risk and the vulnerability into making a recommendation. And this is super important, because at the end of the day, you're likely going to have hundreds of thousands of vulnerabilities where the vast majority of them are completely irrelevant, because they are either blocked by security group configuration, they are not really of a service that cannot be exploited in this environment, versus the ones that are in fact can get you breached, even if they are not literally internet facing, but as Doug said, maybe behind the load balancer, VPC, etc. So we use this data to prioritize, and this is the way that we can, for example, tell you, this is a vulnerability that you, let me find a nice example on that. That is on a machine that is internet facing, a service which is internet facing, and therefore you do want to fix it soon. And these are the minority of the alerts, versus alerts that literally are not that important. The CVSS score is a very, very small part of that, because at the end of the day, there are hundreds of vulnerabilities that get CVSS score of 10 that doesn't have any real impact, versus few others that might get a CVSS score of 5, like Heartbleed, that takes the internet down. So it matters about the importance of this actual vulnerability in regards to the configuration of your environments, of your cloud account. And really the cool thing about the cloud is that the data is there. And when you look both inside the workload and read the configuration of the environment, you can put it in the right context.
Fantastic. Want to jump into one more question from the audience real quick before we go through a couple more agenda steps, but definitely want to get to all the questions coming in from the participants. But this one I think is a cloud usage based type question that needs to be identified. And I'm going to do two of these. First ones, and this one's for Avi, based upon Doug's response. Can you show what the UI prioritization shows for those managing the solutions?
Yeah, so.
And that falls into another question of what is your cloud resource requirements on the shared storage, as well as, what are the cloud providers that Orca operates on. So Avi, if you can bring that all together, that'd be great.
So I'll try to answer it all together first regarding how to configure. And this is something that I really love to show, because this is the configuration process. Literally, these 3 steps is all you need to onboard Orca to an AWS account. You just create a CloudFormation template, you get the ARN and you paste it. There is no VM within the account. It's completely SaaS. You don't need to deploy any virtual appliance. You don't need to manage it. There is absolutely no performance impact. Because at the end of the day, we don't run on the workloads, it can't affect any of the workloads. At the end of the day, if you think about that, when you're running a shared cloud environment, you're not really hitting the performance limitation of the physical disks. What you're doing is you get part resources as much as you pay at the end of the day. So when we launch another scanners that have these provisioned limits, we are running against them. So it doesn't affect anything in terms of the workloads, and it's literally these 3 steps. We support AWS, Azure, and GCP. Literally within each one of them is slightly different steps, but it's for all of them literally few clicks. And it's more important than just few clicks. It's the fact that you don't affect anything. So it literally allows you to onboard everything. Now regarding the priority question, so this is baked into our definition, our levels of severity. So we don't use the standard low, medium, high, or critical alerts. Basically, I don't really know what it means. I've never seen a good definition of what high versus critical or medium versus high means. So we decided on 4 different categories, ranging from compromised, an actual case where we know that the machine is infected, that there is active compromise, imminent compromise, which means that we know of a way that someone can breach the environment today. Think of a remote code execution vulnerability in an internet-facing service, with an easy username and password, etc. And in the vast majority of the environments, you'll have very, very few compromise, the imminent compromise, and we use this alert level very, very sparsely. We use it only when we are certain that this is something that you want to handle as soon as possible. Other DOS are the ones that you actually want to handle, the ones that we don't know of an attack vector today, but they are dramatically weakening your security posture. And even for these, we try to aggregate them in a way that makes sense. And I'll give several examples. So for example, if you have a machine that haven't been patched for years, we'll create one Azure DOS level alert on that, showing the number of vulnerabilities. This is, in fact, unfortunately, our most frequent alert. Even though none of these vulnerabilities, we have a way to detect it, we have found a way that it's going to put your organization specifically at imminent compromise risk. The sheer amount of them and the fact that it's likely showing that the machine doesn't have any patch management system applied to that make it an Azure DOS case. Another interesting case that also emphasizes the fact that reading things from both the control plane and the instances themselves is very valuable, is that there are cases that we tell you the machine is vulnerable, but it's because you used a bad baseline image. So we understand the root reason for that. And instead of telling you you have 10,000 virtual machines running 10,000 vulnerabilities each, we can simply tell you this is the base image which is configured not to refresh, or the refresh failed due to some reason.
So I'm going to try to group a couple of the questions that are coming together, because and we've gotten technical on some of this stuff, and I love that. But as a CISO, speaking for myself, I'm not going to speak for anyone else, but as a CISO, one of the challenges I'm going to have is, okay, now I have another tool that I need to be able to monitor, alert off of, and respond to. So, and Avi, your interpretation of the solution, but even Doug and Drew, how have you integrated so that, have you integrated into this SOC? Have you integrated this into your ticketing systems? And how are you incorporating this into how you're addressing all of the different components of your security program in DevOps? Avi, you first.
So at the end of the day, what we allow customers to read the data via versus mechanisms, both via our portal and via ticketing system. Currently, we support Jira. We're adding ServiceNow shortly afterward, so in a few weeks. And
so would you say the first one again? I don't know if it came
Jira.
Jira, thank you.
And we're adding ServiceNow, and everything is, of course, consumable via public API. And the care is really about the prioritization. It's a completely different game if you need, as an organization, 250 Azure DOS alert, you want to take it into a work plan, and 5 imminent compromise, versus the fact that you are just getting 10,000 vulnerabilities and you try to do something with it.
Yeah, I'll build on that as well. It doesn't take a lot of people to run this. I found that we've been able to configure it, put it in the hands of the people that are actually doing the work. And there's really not a lot to maintain on the system, aside going in and making sure that the people are addressing the work. We also roll the results from this up, because, as I said earlier, we're in a hybrid environment. So I also take the results from this tool and the asset information it gives me, and roll it up into another system that correlates across many of my other security control tools, and builds a broader asset management system across my organization. So it feeds that very well, in addition to finding the vulnerabilities.
Let me jump in there too. Jira is the one that we've settled on for now, and very similarly, it's a matter of going through and looking at eyeballing what Orca has identified and then creating the JIRAs and then, working it through the workflow to go through and clean that up. That's where these things do fall into the CI/CD pipeline to make sure that, any vulnerabilities that are being replicated across multiple systems can be fixed proactively or at least mitigated across the board when we identify them through this process.
Fantastic. Wanted to follow up and keep going down this theme of the authorization of Orca. Avi, across your customers, I'm not gonna dive into Drew and Doug's specifically, to start measuring the size of their organizations. I don't think that's fair. But on average, what are you seeing your customers on the amount of people or resources that they're using to operate and manage the Orca solution? And then about an implementation timeframe for initial implementation of visibility versus incorporation into a SOC or an orchestration process?
So naturally, it depends dramatically if you're talking about a small shop or a large Fortune 100 company. But the implementation itself is very, very simple. It's a few clicks. There is nothing you need to do beside clicking and having this visibility. And it's literally that, and you get the visibility in the console. Now the question is what you do with it. What we found out working with our customers is that most of them tries to, especially the larger one, divides the alerts between the imminent compromise and compromise that are going to the SOC that they want to handle in a very short time period. These are usually the things that you do want to be handled ASAP, versus the things that are hazardous, that many times are routed to the engineering teams, that the ticket is created, that are being monitored, things like embed-based images, things like keys that are not secured correctly, everything that dramatically weaken the posture. Many times it's not within the SOC in the large organization, but something that is moved to the engineering teams. But the more severe ones are usually things that the security teams want to handle themselves.
Fantastic. So this is a question that I like to ask because I know what my answer is to it, but I think it's fair, and I think some of the questions and some of the conversation that we've had today, really falls into this. But Orca is a cloud tool, and the cloud's one. We understand that everyone is looking to go to the cloud. They're looking for digital transformation. Most companies have some cloud presence today. But when we look at risk management and we look at information security, let's be honest. What's the uniqueness of the cloud, or what's different? What makes cloud different, and what are those challenges? And are they really new or unique, or is it just a different perspective of the same kind of challenge? Drew and Doug, I'd love to hear your perspectives, both coming, one from a cloud-born company and then also from a company that's moving to the cloud and that has legacy on-prem as well. What are your thoughts on this?
Well, let me start. I think that coming as a CSO who has started out in an on-prem world, and frankly, without dating myself too much, I've been doing security long before there was really the concept of a cloud. Has really it's really driven my thinking, and I think the cloud it does add a lot of efficiencies, and it makes it happen a lot quicker. But there's a lot more risks too, because there's a lot of people that have this mistaken understanding that security is on by default in the cloud, and it equally has to be configured and maintained and monitored just like any environment in a data center. So I think that the cloud, while it does provide some benefits, it does still carry the same traditional challenges.
Yeah, I think building on that, some of the blessings of the cloud, so to speak, are also the curses. There's no doubt that the cloud makes it obviously a lot faster to deploy things, get your code up and running, and get to productivity very, very quickly. And the sheer fact of bypassing the IT infrastructure teams allows people to move more quickly and move with agility. But let's not forget that sometimes the reason it took the IT teams longer to deploy technology on premise, so obviously aside from the racking and stacking of boxes, is there was more consideration taken to the ongoing maintenance and the workload for maintaining things on there. And just because you can build something in the cloud, it doesn't necessarily mean that you're qualified to build it in the cloud and maintain it from that. So to some extent, the consumerization, if you will, of IT has created its own dangers there, because people are moving with speed, and let's face it, not everywhere has got immutable images and a clean CI/CD process. There's a lot of lift and shift that's happened into the cloud with basically P2Vs and just kind of running, you know, if they were crappy VMs when they were on premise, they're crappy VMs when they're in the cloud. So there's a danger there that becomes easier and quicker, and it just doesn't solve all the problems.
Doesn't that fall into the kind of misconception that it's safer or less risky because, you know, if you need to, you can just turn it off and you don't have that capital cost or that impact. But that at the same point is the scary part for me, is that because it's that easy to turn it off, it's that easy to turn it on.
If
Yeah,
I
I think
can
it
add
goes both ways. Go ahead.
Yeah, I think that one of the things that I see is that people confuse what they call the culture of the cloud with the cloud. So, you know, they expect things to be available tomorrow. They create a POC, show an application, and everyone expects it to be up and live tomorrow. And many of the checks and balances that we used to have of checking what's going on, whether they have the processes to maintain it, are left around. And it's not related to the technology of the cloud, but to a mindset that, okay, let's try and break. But security doesn't always work that way, because try and create a risky situation for the organization can manifest in dramatically larger cost than the scope of this specific service.
Right. So there's the urban myth out there is the engineer that spun up 5,000 instances and then just parked them all in a corner just in case he might need them later. But I think this is actually a fair question, is, you know, and I'd like to know, you know, what your thoughts and whether or not Orca can help with. Let's talk about forgotten assets in the cloud. Because for me, that's a big deal, but I'd like to hear your thoughts on that, Doug. Drew?
Well, it's a thing. I mean, it simply is a thing. I think anybody, if they're honest and they start looking at their assets in there, or really start getting a handle around what's going on, is once you start chasing these things down, it's not uncommon for somebody to say, oh, I'm not using that asset anymore, I'll just spin it down. We'll just make it disappear. So in reality is again, it happens. It doesn't happen in every environment, but it happens.
And then all of a sudden, 18 months later, it's like, oh yeah, I have that and I need that today, but it's gone, spun down, and having no attention for the last 18 months. So it must still be hardened, right?
I think one of the things that we see, and we even coined the name the neglected workloads, simply think that someone spun up, it's so easy. Maybe it was a POC, maybe it was a side application, maybe it was something that was done outside of the IT, sitting there unmaintained totally. Many times it have critical keys or critical data, never patched, sometimes already infected, and nobody knows about that. The IT never had a clue. Many times wasn't even done by the IT. And this is something that the on-prem environment was simply, there was no solution to that. It was also harder for that to happen because you needed to buy a box or get approval for that to be communicated externally. But it's much easier in the cloud, and there is a solution. There is no reason that you won't be able to see inside of your workloads, regardless if someone integrated them with your environment or told you about them.
All right, last question, and then we're right on the hour, but I want to get this last question in. I'd like a quick response from all of you. So as we look out past 2020, and I'm not going to comment about what's going on in 2020 right now. That's a whole different conversation. But as we look out past 2020, what are some of the challenges and opportunities that you're seeing with regards to cloud and cloud security?
I think the continued challenge is going to be, can your security program move at cloud speed? Can you keep up with the pace that we're going to be deploying and spinning things up and spinning things down? And for a lot of security programs and teams, we have to start thinking differently. Our traditional tools and methods just won't work, and frankly failed us to a certain extent when we were dealing with it on premise, and they're going to fail us even more in the cloud. So I think we're going to have to continue to evolve at that pace, and the challenge is going to be, can we evolve our security stack as quickly as cloud technologies are evolving?
Drew, what's your thoughts?
Yeah, I think I would say the same thing. I mean, look, at the end of the day, you know, and we've expressed this, you know, spinning something up in the cloud is easier, but it's also a lot less secure natively out of the box if you don't follow the fundamentals. So if people are not paying attention to the fundamentals and paying attention to the fact that security is still a valuable part of the lesson, then it's going to get us in more trouble with the cloud. I mean, I think, you know, Roger, you and I have talked about this, where I've had vendors come to me and say, oh, I've got this new cool thing I want you to try out. And I ask a few questions. They go, well, we're in Amazon, we're in the cloud. That makes it secure, right? And that false sense of, or that lack of really paying security its rightful due is going to hurt customers and the companies that produce the solutions. So it still becomes very important that we follow the fundamentals and that we continue to do the basic security analysis of things, regardless if they're on-prem or in the cloud.
Drew, don't get me started on that conversation again. We'll be here for hours. Avi, where do you see Orca coming in the future through 2020 and beyond?
So the way I see, I'll answer it generally for the industry. I think that one of the things that security tools need to be is really cloud first. And when I say really, it's not just marketing, is understanding that this is new world out there. Things are built dramatically different, and you need to think of the best way to do it for this physics, for this environment. If we'll just continue to use what we had that was built based on the limitation of physical machine and, you know, package it in a cool cloud way, we'll be working with limitation that no longer apply. So we are really believing that some of the major players are focusing too much in just saying, we want to have the same for the cloud and the on-prem. And it ends up getting something which is not optimal both for on-prem or for the cloud. These are different beasts that have different limitations, and we can do security in a dramatically better way for them. It's no longer a niche market.
Fantastic. Drew, Doug, Avi, I want to thank you so much for your time. To the attendees, I'd like to thank you for staying with us through this hour and for the participation. And if you have any more questions about Orca security, please don't hesitate to send them an email at orca@orca.security.
At info@orca.security.
Thank you. Info@orca.security.
Thank you.
Thanks, everybody.
Thank you.